Hello guys, this is your tutor Hlongwana PE. In this video we are going to be looking at partial fractions. Partial fractions are very useful when you are doing integration. So it is very important that you look at partial fractions carefully before you go on to tackle questions on integration, so that you can be able to know how they look in different formats. So let's look at the first format of partial fraction. So the first one, doesn't matter how you say which one is your first, but I chose my first one to be the one of linear factors because also it is the easiest one. So when we are having px plus q over x minus a into x minus b, when we resolve this into partial fractions, what we get is a over x minus a plus b over x minus b. Then again, this can also be generalized in this manner, plus pqr over. Now in this case, you are having more than two factors, say a, b, and c. Then when you expand it, it's going to be plus b over x minus b plus c over x minus c. So let's look at an example that involves the first one. And then we'll say that this is example 1. If we're having something like x plus 2 over x into x plus 3, we can see that if we resolve this using the first formula number a, it will simply be a over x plus b into x plus 3. So we want to resolve this into partial fraction. That is what we are trying to do. So we need to find the values of a and b in this case. How do we find the values of a and b? We firstly multiply both sides by the denominator of the left hand side, whereby we'll end up having x plus 2 is equals to a into x plus 3. And then this side we have bx. Then if we let x to be negative 3, so here it is your choice. We just have to let x to be any number that will be able to help us get rid of a or b, so that we can solve one constant at a time. So if I let x to be negative 3, I can see that on the left hand side I'll have negative 1. Then where is a, negative 3 plus 3 is 0. Then I will have negative 3b. Then solving here, I will end up having b over 1. Then again, from my partial fraction, I was here. After multiplying both sides by the denominator of the left hand side. So this time around, I can let x to be 0. If I let x to be 0, I can see that if I put 0 here, I will have 2 equals to a into 3. Then the b will be gone this time around. Then I will end up having 2 over 3 for a. So what I need to do is to resolve my function into a partial fraction. Where I see a here, I put 2 over 3 over x Then when I see b here, I put my b was 1 over 3 x plus 3. So we have actually successfully resolved into partial fraction. However, we can simplify further, and then we rewrite this as 2 over 3x plus 1 over 3x plus 3. So let's look at second example under linear factors again. If we're looking at another example under linear factors, we can look at this typical example: 2x squared minus 5x plus 7 all over x minus 1 x plus 2. So we can see that if we want to resolve this into partial fraction, we'll resolve using formula number b. So it will give us a over x plus b over x minus 1 plus c over x plus 2. Then we can multiply both sides by the denominator of the left hand side. Then we end up having 2x squared minus 5x plus 7. Then here on a, x will be gone. Then we'll be left with x minus 2, x plus 2. Then here x minus 1 will be gone. We'll be left with x and x plus 2. Then here x plus 2 will be gone. We'll be left with x and x minus 1. So again, we need to know how to quickly solve for a, b, and c. So initially, I can let my x to be 1. If I let my x to be 1, on the left hand side, I will have 2, putting 1 there, minus 5, put 1 there, plus 7. Then I can see that if I put 1 on a, x minus 1, it will be 0. Then if I put 1 here there won't be 0, so it will be 3. But if I put 1 here, see, it's going to be 0 that side. Then this side, solving here, I end up having 4 is equal to 3b, where my b becomes 4 over 3. So the second step, I can let now my x to be negative 2. We are still working on this equation. From that equation, if I let x to be negative 2, initially I have let my x to be let my x to be 1. Now I'm letting my x to be negative 2. Negative 2 square minus 5, negative 2 plus 7 is equal to. So I can see if I put negative here, this will go to 0. If I put negative 2 here, this will go to 0. Then I will be left with only c. Where there's x, I put negative 2. And then I will have negative 3. Then 25 will be equal to, solving this will give me 25, 6c. Then c will be equal to 25 over 6. So now we have found c, we have found b. What we are left to do is to find a. So we said that our equation was 2x square minus 5x plus 7 is equals to ax minus 1x plus 2 plus bx. It's bx what? X plus 2 plus cx x minus 1. So here, if I let my x to be 0, I will have 2x to the power 2 minus 5, 0, plus 7 is equal to, here I will have a 0 minus 1 is negative 1, x plus 2, x plus 2, I'll put 0 is going to be 0 plus 2, which will give me 2. So these ones will be gone because bx, if I put 0, it's gonna be 0. If on the cx, if I put 0 on the x, it will be gone. So I will end up having 7 is equal to negative 2a. Then when I solve my a, I will have negative 7 over 2. What I'm left to do is to use my initial equation, which was 2x squared minus 5x plus 7 all over, let me confirm, it was x minus 1, x plus 2, which was a over x, b over x minus 1, plus c over x plus 2. Where I see a, I put my a. So it's going to be negative 2 over 2x. Where I see b, I put the value that I found for b. My b was 4 over 3. So it's going to be 4 over 3x minus 1. Where I see c, I put 25 over 6. So it's going to be 25 over 6x plus 2. So now we have solved partial fractions using linear factors. Let's look at another technique, and this technique is known as repeated linear factors. Repeated linear factors. So in repeated linear factors, you are given something which is in this nature, x minus a square. So when you do this, the way you resolve them is x minus a plus b. You don't say x minus a alone, but simple x minus a all square. That is the formula for a repeated linear factors, and we can generalize it by p x square plus qx plus r all over, then maybe we'll have x square, then b. In this case, we can see that this is a repeated, so it's going to be a x minus a plus b. We apply what we did on formula number a square, but we should remember now that we are having b also. So that is the format that it will take. So let's look at an example where we can apply this. So let's look at an example that actually applies formula number b, because formula number 1 will be straightforward, but we'll just look at an example that apply actually both of them at the same time. So, and then we'll call this to be example number 3, because I think this was example 1, and then this was example number 2. Let's call this to be example number 3. And then if we're having x squared plus 2x minus 1 all over x minus 1 square. The moment we see a square, it means that it's a repeated factor, then x plus 2. So it means that when we resolve this into partial fraction, we are having a repeated factor at x minus 1, then x minus 1 again, then we square, then plus c over x plus 2. That is simply as that. That is the way we do it. So what we do from here, as we did from the previous examples, we multiply both sides by the denominator of the left hand side, and then we'll end up having x squared plus 2x minus 1, and then x minus 1 will be gone on a when we multiply by that, but it will remain actually like this. Then on b all square, then c, it will be cx minus square. So you can actually just multiply both sides by the denominator of the left hand side. You will see that it will work out to be this step. So from here, I can see that what can I choose my first value? If I let my x to be 1, what do I get? I'll have 1 square plus 2, 1, negative 1 into here. If I put 1 on the terms that contain a, it will be 0, and then even b will be gone. Will b be gone? Yes, b will be gone, but I actually wrote it in a wrong way. This is not actually this. Let's just fix that step. B is actually going to be x plus 2, not x minus 1 square. Then if I put 1 inside b, it's going to be b into 3. Then if I put 1 where there's c there, we're going to get 0. This should work out to give us that b is 2 over 3. So it is very advisable that you look carefully at these, because it is very easy to make a mistake. So let me rewrite my equation from the start, because now I have solved the value of b. I've only solved the value of b so far on example number 3. So it's going to be x squared plus 2x minus 1 is equal to a into x minus 1, x plus 2 plus b, x plus 2 plus c, x minus 1 all square. So again, if I let x to be negative 2, what is going to happen? I will have negative 2 square plus 2, negative 2, negative 1. Then here, a will be gone. I'll have 0 if I put negative 2, because I can say I have x plus 2 on a. And then even b, I have x plus 2. Even b will be gone, so I'll have plus 0. On c, it won't be gone. I will have negative 3 square this side, if I solve this side, I'll end up having negative 1 is equal to 9c, which gives me that c is actually equal to negative 1 over 9. So I have found B, I have found C. I don't have A. So at first I chose my x to be 1. Then secondly, I have chosen my x to be negative 2. So let me choose my x this time around to be negative 1. Is it going to be helpful for me to choose? Yes, but you can choose any number of your choice. So negative 1 square plus 2 into negative 1 minus 1 is equal to a. Then it's going to be negative 2, 1. Just substitute negative 1 where you see x from this equation. Then it's going to be plus b, negative 1, then c, negative 2 square. Then this side I'll end up having negative 2 is equal to negative 2a plus b plus 4c. So I can see that this time around I was not able to get rid of the values of b and c, but I actually do have those values. If I can put, because I'm looking for a right now because I've solved for c and b, so negative 2 is still there. A is what I want. Then what is the value of b? B is 2 over 3. So it's 2 over 3 plus 4. C is negative 1 over 9. What do I need to do? Solving this equation will lead to that A is actually 10 over 9. Then from here, initially my equation was x squared plus 2x minus 1 over x minus 1 all square, then x plus 2 is equal to that. I want to resolve into partial fractions. So it was a over x minus 1 plus b over x minus 1 square plus c over x plus 2. I have found the value of a, I have found the value of b, I have found the value of c. Then from here, my value of a is 10 over 9, so I can say 10 over 9 x minus 1. What was my value of b? My value of b was 2 over 3, so it's 2 over 3 x minus 1 square. What was my value of c? It's actually a negative, so it's just advisable that I just write 1 negative 1 minus 9 x plus 2. So we have dealt with repeated linear factors. So there are cases whereby we don't have linear factors. Then it is what we are going to be looking at this time around. If we are having irreducible factors, and some people they call it quadratic. So what is an example of a quadratic? Quadratic can be something like px square qx plus r over x minus a, then x square plus bx plus c. It is provided in this case that x square plus bx, it is not possible to factorize it. So you cannot change it into other brackets. So we'll have x minus a plus bx plus c over x squared plus bx plus c. That is the most general form of irreducible factors, also known as quadratic factors. So what is an example of quadratic factor? Let's go and look at it. So I think this time around we need to be careful when we are looking at this because it's a bit tricky. So we will say that this is example number 4. If we are having x over x squared plus 3 all into x plus x squared plus 4. So let's rewrite this properly. This is actually x squared plus 4. X squared plus 3 cannot be factorized. X squared plus 4 cannot be factorized. So when we reduce here, we will apply this formula of irreducible factors. So we will focus here. If we cannot factorize, we focus on that step there. So it means x squared plus 3 is not factorizable. So we can say it's ax plus b over x squared plus 3 plus, then we will say we just continue with alphabets of our choice. So it's 6x plus d over x squared plus 4. So what is happening right now? We do the same thing as we did from previous examples. What is going to happen is that if we multiply by the denominator of the left hand side, we'll end up having x is equal to ax plus b. This one will be gone. So we'll end up having x squared plus 4 here. Then plus cx plus d into, this one is, they are actually all multiplying each other. Even here, it's all multiplying each other. Then we'll have x squared plus 3. So we can see that here we cannot use the method of letting x to be 3, letting x to be 4, because it's not going to get rid of anything here. It's not going to be very helpful. So what we need to do, we're going to use a method that is known as a technique of using coefficients. So if we have x is equal to, we can actually expand here. If we expand the brackets on the first one, we will have ax to the power 3 plus 4ax plus bx squared plus 4b. Then this side will have cx to the power 3 plus 3cx plus dx squared plus 3d. So what can we do? in this case, we can group coefficients together. If we're having x, let's group the coefficients of x to the power 3 initially. We're having a, and then where again do we have x to the power 3? We are having c. We just factorized there. Let's group the coefficients of x to the power 2. We are having b, and then we are having d. Let's group the coefficients of x. We are having 4a, we are having 3c. Then plus, let's group coefficients that do not have anything. We are not going to group them, but let's just write the coefficients that don't have x variables. It's going to be 4b plus 3d. Then we will start. We'll say x to the power 0 coefficients. On the left hand side, what do we have? We don't have x to the power 0 coefficient, so we'll say it's equal to 0 plus 4 is equal to 4b plus 3d. Then this, we can see that b can be just negative 3d over 4. If we continue again, let's look at x coefficients. X coefficients. The x to the power 1, actually. Coefficients. We can see that on the left hand side we have x, so we'll say 1. Then the x coefficients that side will be 4a plus 3c. Then we can focus on x to the power 2 coefficients. X to the power 2 on the left hand side. Now we don't have, because we only have x on the left hand side. We only have x. Even here, it's only after expanding, we can see that we only have x. So x to the power 2 coefficients, we don't have anything on the left hand side. So it's going to be 0. Then it's going to be b plus d. So we have seen that here, when we're having x to the power 0 coefficients, we're having b equals to negative 3d over 4. So when something like this happens, we can see that we're having two equations that have b and d. So we can say that b is equal to negative d. What is going to happen now? Wherever we see b, we can substitute this in b. So it's negative 3d over 4 is equal to negative d. We can see that everything is cancelling. So from here, we can conclude that d is actually equal to 0 and b are zeros. So let's continue and with other coefficients, because we were at coefficients number 2. Look at the last coefficient, which is actually x to the power 3. So it's x to the power 3 coefficients. So we can see that when we look at our equation, this side, we don't have x to the power 3. So again, we'll write 0. So just take note if you were lost on the previous step when I was doing this. So on the right hand side, the only place where we have x to the power 3 is here, where we are having x to the power 3 into x plus a. So we will have only a plus c, actually not x plus a plus c. So these are the coefficients of x to the power 3. So we can see that here we are having a can be equal to negative c. And then do we have another equation that has a and c? Is that one. 1 is equal to 4a plus 3c. So it's 1 is equal to 4a plus 3c. So I can see that c is actually negative a. So if I put negative a where I see c, so it's going to be negative a in the place of c. I will end up having 4a minus 3a. Then 1 is equal to 4a minus 3a. It's a. Therefore, we can see that a now is equal to 1. And again, c will be equal to negative 1. In that case, what we need to do, we need to go and substitute our variables in this equation, which was, it was x over x to the power 2 plus 3 into x squared plus 4 into ax plus b over x to the power 2 plus 3 plus cx plus 3 into x squared plus 4. So what we need to do is to, we said that b and d, there were zeros. We found that a was 1. So what we can do, 1 times x is just going to be x over x squared plus 3. Then we said that c is negative 1, so this side, and d is 0, so we're going to have negative x over x plus 2. So in this case, we have completely solved partial fraction where we are having irreducible factors where we cannot be able to factorize. So let's look at the last one, but we won't solve for the purpose of time, and I believe that now you must be tired. Let's just look at the formula for the repeated irreducible factor. So you can just take it this way. If it is in this case, we can see that we cannot factorize x to the power 2 plus 3. Then this one will be a x plus b over x squared plus 3 plus cx plus d over ax squared plus d. So that is the way you can do, because we can see that it is repeated and it is not solvable. So that is for today. We will end here. Thank you for watching. Just like this video and subscribe so that you can stay tuned for the next content. Until next time, thank you.